So I'm here to talk to you about IOC container. I'll show you what IOC container is and what it stands for. But first, tweet about this with Laracon EU and follow me on Twitter. So my name is Hannes, and I can describe myself with 4 emoji characters. I am a Belgian, so I'm living in a neighboring country. I like to run. I run marathons. I work with computers, like a lot of you guys do. And I love to make digital products. The last one isn't really an emoji character, but it is a company logo. I work for a company called, this is no longer working, okay. I work for a company called Made with Love. So we make digital products with love. It's a Belgian company, but we have a lot of remote employees, like in France, Portugal, Canada, Brazil as well. So if you want to join us, just sign up and we'll do some talking and yeah, we'll check you out. So onto the technical part of this talk. I will be talking about the IOC container. But what is IOC? It stands for International Olympics Committee. No, that's a joke. It stands for Inversion of Control. In order to explain inversion of control, I'll have to explain a couple more design patterns. So what's best to show off design patterns is to show some code. So let's show some service class. You have a service class with a constructor and a calculate method. Obviously, the service will calculate something and return the result. In here, the calculate method gets some files from FTP, does some calculations on it, and returns the result. When the project comes along, you want to add some caching and some logging here as well. So you can know what is actually being fetched from FTP and when it is fetched. So you want to prevent hitting the FTP over and over and over, so you want to cache something. Obviously, this is a single responsibility, a failure against the single responsibility principle, which is one of the solid principles. So if you look closely, you will see that the FTP word appears often. So you do something with FTP, you cache the FTP, you log what you do with FTP. So obviously, this is not what is supposed to be in this class. This method name is calculate, so you should calculate something, not do all this FTP stuff. So we should refactor this. You also see that we inject an FTP class in a constructor. So what if we move that to a different class, the FTP stuff? So getting something from FTP, caching it, and logging it, we move that to a different class so that the service class is clean. It only calculates it. So we create an FTP storage class, which again needs the FTP class, but the FTP class is no longer needed in the service class. So we inject that here. Obviously, this is still a single responsibility constraint, a mistake against the single responsibility principle, but it's better in the service class. The service class is improved. If we look at the service class, we inject the FTP storage class instead of the FTP class. So it's, we depend on the higher level abstraction instead of a low level implementation. The next thing we can do is to interface the storage class. You know, when the project comes along, you get something from FTP, but the ones that manage the FTP server might switch to, let's say, HTTPS or S3. So you want to abstract this. You want to create an interface. This interface has a simple method. It has the same method signature as the get method has on the FTP storage implementation. So public get file name or key. Then we simply have to make this FTP storage class implement it. It's very simple. Add implement storage. The next step is to refactor the service class again. We want to inject different storage objects as well, not only the FTP storage class. So in here, in the constructor, we inject something that implements that interface. This is called dependency inversion. We point to a higher level abstraction instead of to a lower level implementation. So in here, we inject any storage implementation. So what if we need to create a service class, a service object? We need to do new service. Well, first we need to create a new FTP server with some settings, an array of options, like the host name, the username, the password, stuff like that. Then we need to create a new FTP storage class. And then we need to create a service class. That's a bit much to do, no? This is my advice. Don't create these instances yourself. Let the container do that. That's what the container is for. So that is what inversion of control is. You don't need to call these objects or new up these objects yourself. Let the container do this. The IOC container is here to rescue. So I told you that the FTP storage implementation is still not single responsibility. It still doesn't have one single responsibility. So we have this interface now. What we can do is create wrappers or decorators. This one is for caching. We can use this caching decorator both for the FTP storage class, for the S3 storage class, for the HTTPS storage class, and whatever you want, or local file system, whatever. So you can use any cache implementation, inject a different storage class, create a new get method. The get method fetches the cache first. If that doesn't have a valid cache value, then it will proxy the call to the actual storage class that has been wrapped by this class. So that's what a decorator looks like. You can do the same with logging. So if you go to the storage class, which implements the storage interface, we can see that it only has knowledge about an FTP server, and that the only thing it does is get the result and return it. So it's super single responsibility, and it's super unit testable. If we go look at the dependency graph, which is the tree of all the interfaces and classes in your project, then you can see that there's a service class which depends on any storage implementation, which is an interface. So the interface is at the top of the dependency graph. And every node in this dependency graph has arrows that go up. They only go up. So you only depend on higher level abstractions. This is a good dependency graph. If you have downward facing arrows, then there's something wrong with your architecture. So the FTP storage class here depends on FTP and also implements the storage. Note that the classes, the leaves at the bottom of the array or of the graph, are actually the most low-level implementation classes in your entire project. So we have different implementations for the storage interface. We have the FTP storage, the S3 storage, and the decorators. They're all children of the interface, of the storage interface. So that's the dependency graph. So I showed you a couple of design patterns here. The first one is dependency inversion. You depend on a higher level abstraction. You point upwards. So you depend on the storage interface and not the FTP storage or the S3 storage or whatever. The second one is dependency injection. You've seen a lot of constructors with type hints. You see, that is constructor injection. That's one of the forms of dependency injection. So you inject whatever this class depends on. Whatever the service depends on, you inject it via the constructor. So that's dependency injection. Inversion of control is very similar to dependency injection, and it works together. So inversion of control is saying, you don't need to you don't need to new up all these instances. We'll give them to you using dependency injection. So those two work together. So the inversion of control container is a container that you can use to new up a service class. So you say container get service class. In Laravel, this is this app make service class. What this method does for you is it makes an FTP storage class. It wraps it with a log decorator and a cache decorator. It depends on your needs if you're going to wrap it with the cache decorator or the log decorator first. If you want to log only when actual FTP server is called, then you want to wrap that first before wrapping it with the cache decorator. And then you want those wrapped objects to be injected into the service class, because you can inject a log decorator instance because it's type-hinted storage interface. So that's what the container does. That's what it's used for. It's used to help you with creating new objects without having to walk the entire dependency tree to create it. So the IOC container is here to help you with composition. If you go to packages.org, you can see that there's a couple of implementations out there. The first one is Laravel's container, but there's also different containers like the Leak container, Symfony dependency injection, RRDI. A lot of these containers are used in different frameworks. And to be interoperable between frameworks, there's also the container interop package, which is a set of interfaces that you can use to swap out different containers between whatever application you have. If you have a microservice that you want to use a different container in that microservice, then you can swap that by using the container interop interface. Note that the Laravel container does not adhere to this interface, but that's solvable by just wrapping it in an adapter. So no big deal. Bright slide, just to blind you. So Taylor yesterday told me that one of the first features that the container had was to use a PHP feature to do automatic constructor injection. So what that means is, if you have a TV is being shut down, select OK. Oh, it's not touchscreen. OK, too bad. So if you have this class, sendInvoice class, and it needs a mailer, then the IOC container of Laravel can actually look at this constructor and see that, oh, it needs a mailer. So to create this class, I need to create a mailer first. So it's a recursive thing. By doing that, it looks at the constructor, and it tries to do constructor injection to new up these instances. So if you do this app make sendInvoice class, it will use reflection, which is a native PHP feature. So we have a reflection class, which is in the global namespace, and you pass it the class name, then you can get the constructor reflection method class. This monitor has turned down. Now this will shut down in 51 seconds. You can see this, but I can see this. Right. And the constructor has a couple of parameters, and you can inspect those parameters and see what the type hint is. And based on the type hint, the IOC container of Laravel will try to make those new objects first before injecting them into that constructor. So that's what the IOC container does recursively. It first creates a mailer class or one of those dependencies first before creating the mailer class and then the sendInvoice class. But like I showed you, sometimes you type in an interface. You can't new up an interface without telling the container what actual implementation to use. So we need to help the container from time to time. And that's what this chapter is about. Now I have no monitors left. Cool. I'll just use my monitor. So in Laravel, we have this thing called service providers. Service providers are classes that you can register on the framework. So you can say to the framework, when you boot up, listen to this service provider. It will tell you some things to the IOC container to help you with IOC things, so with dependency injection. If you look at an example of a service provider, thanks. The service provider has a method called register. The register method is there to tell the service provider, to tell the IOC container to hint at some stuff. So in here, you will say this app, when this needs that, give that. Some contextual stuff like that. It also has a boot method. And when the framework is booting, it will call all the register methods of all the service providers. And when it's done with that, it will call all the boot methods. You can use the boot method to inject stuff. So it will look at the type hints. In here, this boot method has a dispatcher type hint. And it will actually create a dispatcher, an event dispatcher, before calling this function. So if you type in the dispatcher object here, you can use the event dispatcher in this boot method. That's why you need to, when you need to call the event dispatcher, you need to put it in the boot method, not in the register method, because otherwise the order of the service providers matters. If you put it in the boot method, it doesn't matter. So you can put it there and don't care about it, where or when the service provider has been called. You can also defer a service provider. So you can say, well, I don't want you to call this register method just yet until you need something that is in this provides array. So when you need a mailer or a Swift mailer, only then can you call the register method. And only then will this service provider register its bindings to the IOC container. So I've been talking about register bindings to the IOC container, but how does it look like? In this service provider, you can use this app. This app is the application container or IOC container. You can use the bind method to bind stuff. So this app binds mailer contract, which is an interface, when someone is resolving a mailer contract class, then give it a Swift mailer instance. This is a binding. You can also use an anonymous function or a closure. When someone needs a mailer class, then execute this function and return the result of this when someone wants the mailer class. So in here, you can do stuff like wrapping it with cache decorators or log decorators or whatever. So every time someone requires a mailer class, this function will be executed. If you want this to be executed only once, then you use this app singleton. The result of the anonymous function will be kept in memory, or the container will keep a reference to it and will reuse it whenever someone wants to inject a mailer class. So you only end up with one instance. You can also use the alias method. This app alias, mailer class mailer. This is something that has been added later. The first iterations of the IOC container only had the class names. And now you can also add some aliases or strings, just simple strings. If you do this app make mailer, not a full mailer class, fully qualified class name, but just a mailer string, which is 6 characters, then you can get the same object. My advice is to bind a concretion for every interface. We have some PSR interfaces, like the logger interface, the cache pool interface. We have, I don't know, like a PSR 7 request object interface, request interface. You can bind concretions to those interfaces. So whenever someone or whenever any class in your project tries to inject something which is interface typed, then you can actually provide it with a concretion. Bind everything with its class name as well, next to its interface name. So when someone tries to inject a guzzle response object or a request object, then you can actually give it a guzzle request object. Unless you bind multiple versions. So let's imagine this case. We have a file system abstraction like fly system, and you have different folders or different fly system interfaced objects which point to different folders. You have the photos folders, you have the files folders, you have the documents folders. When you want to inject those, you can use plain strings to call them. You can say this app make fs.photos, and it will execute this first anonymous function. By doing this, you can also use contextual binding. Anyone knows what contextual binding is? Let me show you. Let me see some hands. OK. Some familiar faces. Contextual binding is actually telling the container that when some class needs some implementation, then give it this implementation. For example, when a photos controller needs a file system interface, give it the fs.photos implementation. I try to avoid using facades. You can use facades if you want, but let me show you this example. You have different database connections, and in some class, you want to use database 1. And on that database, you want to get some table and do some query on it. When this situation occurs, some people do database connection, database 1, table something, and they use the facade. But what you can also do is bind database 1 to the IOC container, and when this event listener needs database 1, then you can give it db1. So when event listener needs a connection interface, which is an interface by Laravel, then you can give it database 1. And in this anonymous function, you will say this app db connection db1. If someone needs db1, give it this app db connection db1. This is prettier, and it's also a lot more testable. When you need to test this event listener, you can inject whatever mocked object of connection interface and pretend like it's db1. The next thing I want to talk about is inflection. Anyone knows what inflection is? I'll give you a more common name. It's called container events. This rings a bell? No? OK. Container events. Let's show you what container events is. So when a container is resolving an object, you can actually tap into the container's flow and say, when you're actually resolving this, execute my callback first. And this callback will be called with that actual object that is being resolved. So if you're resolving foo, you can say this app resolving foo, function foo, and do something with it. This is useful for a lot of things. One example I have is an environment-aware interface. So if you want an object to be aware of the environment that the application is in, if it's testing or local or production, then you don't need that object to be aware of the application class, the full application class. You can set that environment via method injection. That's a different form of dependency injection. So you can set that environment on that object. So the environment-aware interface looks like setEnv. It has one single method, setEnv. If you go look at how we set that up in our IOC container resolving process, we can use container events to, when some environment-aware object is being resolved, then set the environment. Use this app environment to get that environment key and inject that via method injection by using setEnv on that environment-aware interfaced object. So we can use this interface, and we can use this trait to actually set that functionality on any object we want. So we can say implements environment-aware and uses trait environment-aware trait. So this environment-aware trait has setEnv method, but also has a protected or private isEnv method, which returns a Boolean. So you can quickly do the same thing as you do on the application. So you don't have to inject the application everywhere. You can inject what you need from the application, like the environment, into every object as you want. So that's called method injection. What is it useful for? For quickly injecting stuff like the environment or like a command bus. If you need a command bus somewhere, then you can use interface command bus aware and trait command bus aware. The same with event dispatcher. If you need an event dispatcher, you can say interface event dispatcher aware and trait event dispatcher aware and inject a event dispatcher. So it is also used to solve soft dependencies. What are soft dependencies? For example, the mailer class of Laravel has a reference to a queue, because you can do mail queue something, but not always, you don't always call mail queue. Sometimes you do mail send, and then the mailer actually doesn't have to know about the queue. So that is something that is a soft dependency. Only in some cases you need a reference to the queue. So how can you solve this? By using container events, you can say when the mailer is being resolved from the container, set a resolver object or a resolver anonymous function. So when the mailer is being resolved, it gets a reference to an anonymous function, this anonymous function that you see on the screen, which will allow the mailer to get the queue object when it's needed, only when it's needed. So when you do mail send, you don't use the queuing feature, but the queue class is also never resolved from the IOC container, so it's lazy loaded. So it's a soft dependency that you only need in some cases. But when the mailer actually is being called with mail queue, then it needs a queuer object. So then it will call this queue resolver function, which will return a queue class. If you look at the code of the code of Laravel framework, we see that it's being used in several different places. So it's actually something that is being used by Laravel itself. You can get the session resolver, you can get the queue resolver, and so on. So besides method injection and soft dependencies, you can also use it to set configuration variables. For example, if you have some validator which needs to know which file type it needs to allow, and you need that from the config, then instead of injecting the config or calling the config from the validator, you can set those file types using a container event. So when the validator, this should be validator $validator. This is my mistake. So when the validator object is being resolved from the container, then you can get the actual file types that it should allow and set that via setAllowedFileTypes method. So that's injecting some configuration variables. Cool. I've told you how to hint some stuff to the container, but now I'll show you how to use the container to resolve stuff. I would advise you to only use the container in certain environments. So, for example, in factories, when you need to create a new object, you can use a container to help resolve classes. You can also use event dispatchers. Laravel's event dispatcher will also use this. When you need to create a listener, the listener needs to have references to dependencies. So what you can do there is inject a container. The event dispatcher will new up those listeners that are needed on the spot using the IOC container. Same for the router. When you need to create a controller, call the controller method, then you can use the IOC container to new up that controller. So I'm repeating myself here, but the container is only useful in, should only be used in those cases where you need to new up classes. And yeah, that's it. When you need to new up new classes, you can use the IOC container to do that for you. In all other cases, I would try to avoid injecting the application container. So, for example, we can use this app make. When we need to make a file system object, we can use this app make. We can also pass some arguments there, some options. So the second parameter can be an array of options. We can listen to those options by using this app bind And then the second argument will be an anonymous function, which will be called with 2 arguments. The first one is the application container, and the second one are the arguments. In this anonymous function, you can still use this app. This app is in the same scope. The reason why this app variable is the first variable that is being passed to this anonymous function is because before PHP 5.4, so 5.3 and below, you couldn't use this app in this anonymous function. That's why it's still there for backwards compatibility. So the second argument is an array of options. So for example, if you need to make a photos file system, you can say this app make fs photos. And then by looking at the arguments, you can say, oh, well, this file system has to point to the photos root. That's one possible use case. We can also use the call method. So besides the this app make, we can also use call. This call method can be used with an anonymous function. The first 3 examples are exactly the same. So function is an anonymous function, or a callable, sorry. Function is a callable, an array with 2 items. The first one is an object, the second is a method name. That's a PHP callable. The third one is listener : handle. The handle is a static method on the listener class. That is also a callable in PHP. It's native PHP. The third one is not native PHP, but it's Laravel notation. We can use this. We see this notation in the routes file. If you do photos controller at index or something, it means that it will new up a listener first and then call the handle method. What's cool here is that the container will use reflection to see what the arguments are. So the first example says, you need to inject a mailer here. You need to call this with a mailer instance. Laravel's IOC container will call this method with a mailer instance. First, it will create that mailer instance, of course. The same is true for the other ones. And the last one, it will create whatever is needed to inject into the constructor of this listener. And then it will create whatever is needed for the handle method on that listener object. Of course, the result of this function will be returned by the thisAppCall method. One more thing is the wrap method. If you need an anonymous function somewhere that needs to get something out of the IOC container, you can wrap that. So if you need the listener object and the handle method, but you don't want to create that just yet, you can do thisAppWrap. It's the same format as the call method. So you say thisAppWrap, but it doesn't return the result of the handle method, but it will return an anonymous function that you can call without any arguments. So if you call this function, it will new up a listener and call the handle method on it. This is what it looks like. It's very simple. It just wraps it with an anonymous function and says this callback. Some bonus slides. I think I have some time left. Solving circular dependencies. I've told you about optional dependencies, but circular dependencies are a little bit different. Let's say you have a mailer class, which depends on a queue object, and you have a queue object, which depends on a mailer class. That's a circular dependency. If you do that, if you new up a new mailer with thisAppMakeMailer, and it will use reflection to see what it needs, then you know that it uses recursion, so it will end up in an endless loop. So that's a circular thing. You end up in a circular endless loop. To solve that, we're going to use the same technique as we used with soft dependencies. So for the mailer, you can use either the mailer or the queue to make a soft dependency. So in this example, I'm going to make queue a soft dependency of mailer. So we new up a mailer first, and then we can set a queue resolver. And this queue resolver allows you to make a queue only when it's needed. So we can do the same with queuing as well. So we can create a soft dependency. We can create mailer a soft dependency of queue, and then only when the queue needs the mailer, then we can new up that mailer and inject that. So that's the same technique as with optional dependencies. Of course, this doesn't make any sense because you're never going to queue something on a mail. That's a stupid example, but this should suit to explain what a circular dependency is. Next thing is contextual binding for methods. This is something that I experienced to be lacking in Laravel's IOC container, but I'll show it to you anyway. So I showed you contextual binding. When photos controller needs file system interface, give fs.photos. This only works when you have file system interface as a type hint for the constructor of photos controller. But if you need to inject something into the methods, we know that we can do route model binding and inject some model in some method of a controller. Controller. But if you want to contextually inject something there as well, then that is actually not supported. One example would be to use this app when foo controller at store needs a file system interface or queue contract interface, then give the Redis interface, Redis implementation. I sent in a pull request, but sadly, it has been denied. Something that happens. No regrets. So as a quick recap of my presentation, this is nearing the end of the presentation. I talked about reflection, how the IOC container uses reflection to see what the type hints are of the constructor, and then it will recursively try to new up all those instances and inject them into the consecutive constructors. I talked about binding, how to help the container know what to resolve or what to inject. I talked about container events. I also talked about calling the IOC container, how to use this app make and this app call. And then I also talked about a couple of bonus slides because I still have some time. I think we're having some time left for questions, but that's it for me. Thank you.